The remainder theorem. If a polynomial fx is divided by x minus k, so this is my dx in the other video, then the remainder is the value fk. So the factor theorem below that says, according to the factor theorem, k is a zero of fx if and only if x minus k is a factor of f of x. So if it's a zero, if k is a zero, then x minus k is a factor of fx. And it says, for the following exercises, use the factor theorem to find all the real zeros of the given polynomial function and one factor. So the problem stated that they want us to find all the real zeros of the given polynomial function, but then it says and one factor. So they're saying that if this x minus 1 is a factor of f of x here, then that means if I divided it, it would come out evenly and my remainder would be 0. What I want to show you here is the remainder theorem first before we get started with this problem. I think this is interesting. So if I plug in 1 for my k, okay, because notice what this says. A polynomial f is divided by x minus k, then the remainder is the value fk. And this second theorem says k is a zero of f of x if and only if x minus k is a factor of f. So if it is a factor of it, my remainder, which it would be my fk here, should equal 0. So we're just going to plug it in and see. So that's going to be f of 1, because this would plug in a 1 there, that makes it 0. All right, so this is going to be 2 times 1 cubed minus 9 times 1 squared plus 13 times 1 minus 6. So now this is going to be 2 minus 9 plus 13 minus 6. So if I look at all my positives, that's 15. If I look at all my negatives, that's 15. So altogether I get 0, which is what I should get because they said my x minus k, which happened to be x minus 1, was a factor. And that shows you that if a polynomial is divided by x minus k, the remainder is fk. And that's what we see in here. So I just wanted to point that out to you, how these theorems work. So now what we're going to do is we're going to find all the zeros for the given polynomial function. So I'm going to use synthetic division here to actually divide this out so I can find more zeros. So what I'm going to do here is the 0 for this x minus 1 is 1. So I'm going to put a 1 on the outside. And then on the inside, I'm just going to put all the coefficients. So I get a 2, negative 9. Now again, if I'm missing a power term there, I have to put a 0 in place of that. So this is going to be 13, and this is going to be negative 6. Got a cubed, a squared, a linear, and a number. So I filled everything in there. So now, draw a line, drop the 2. 2 times 1 is 2. Now I add those together now, and I'm going to add those together. And that's going to be negative 7. So then I take 1 times negative 7, negative 7. That's going to give me 6. When I add these together now, and then 1 times 6 is 6. I put it there and I add those. Negative 6 plus 6 is 0, which I should get a 6. 0 here. That's my Rx. This piece here. All right, so what we have left now is, now remember when we're dividing by a linear factor here, I'm going to drop this polynomial by a degree. So this is now going to be 2x squared minus 7x plus 6. And that's what I'm looking at now. So if I'm writing all these together, just so you can see what they look like. Now, I'm just using in the sense that division algorithm. I had the x minus 1, and that's times 2x squared minus 7x plus 6. Now we got to break this down, and I'm just going to use trial and error method for it. So that's going to be 2x for that one, has to be. And that has to be not a 2x, but an x, because when I multiply those, that's going to give me that 2x squared. Now on this end, I have a positive plus 6 there. So no matter what, these signs here have to be the same. So either both negatives or positives. But since I have a negative here, these are both going to have to be negatives. Now I have to write them in such a way that I get a -7 when I add them together, but I also have to get a 6 here. So if I put a 2 here and a 3 there, let's see if that works. It's a 2x squared. That's going to be -4x, -3x. That's going to give me my -7x. And then when I multiply these on the end, -3 times -2, that's going to be +6. So that works. So this here is my breakdown. Those are my factors. So if I have the factors, by the factor theorem, I know the zeros. So the zeros are going to be the k there. So how this works is, my zeros are going to be, I'm going to write the word zeros in there, get used to that, are going to be 1, comma, 3/2, comma, 2. And then if I plug this in here, it's going to make it 0. It doesn't matter what it makes these, because 0 times any of those numbers are just going to be 0. If I plug that 3/2 in there, the 2's are going to cancel. 3 minus 3 is 0. So it doesn't matter what happens here and here, because it's still going to be 0 once I times it by 0. And the last one here, once I plug it in here, 2 minus 2 is 0. So therefore, when I times it by the other things, it's going to be 0. And that's what this factor theorem means, that if I have all the factors of fx, then I can say, hey, I know the zeros. And that's what we're doing here.